Hello there, this is Alana Tucky, and I received a request for help with this problem, which is 11.2, number 13. So let me click View an Example here. It says the manufacturer of hardness testing equipment uses steel ball indenters to penetrate metal that is being tested. However, the manufacturer thinks it would be better to use a diamond indenter so that all types of metal can be tested. Because of differences between the two types of indenters, it is suspected that the two methods will produce different hardness readings. The metal specimens to be tested are large enough so that the two indentations can be made. Therefore, the manufacturer uses both indenters on each specimen, compares the hardness readings to construct a 95% confidence interval to judge whether the two indentures result in different measurements. Note that a normal probability plot and box plot of the data indicate that the differences are approximately normally distributed with no outliers. Well, that's a good thing to note because, of course, if we didn't have that, we wouldn't be able to do anything, right? We always need that our data is normal with no outliers, basically from chapter 7 onward. Okay, and this was a small sample, of course. There's only 9 specimens here, so that would be problematic for us if we didn't know that it was normal. All right, so I'm going to copy and paste that data, and I put it right in here so you could see it. So we have our specimens. So it's basically you have one piece of metal, and you're going to measure it, its hardness with the steel balls, and then measure its hardness with the diamond. So like pincers, they're pressing in. And then you take a second piece of metal, and you measure its hardness with the two measurements, and then so on. So you have 9 pieces of metal that are all being measured twice. They're measured once with the steel ball and then once again with a diamond. That is very much a dependent sample. So if you're going to do a test or an interval, you're looking for the dependent sample for means. So in an interval, that would be this part right here. You're going to do a 2-sample mean for dependent samples. And I even tell you which section of the calculator to look at. It's the t-interval. So this is your formula, d bar plus or minus t alpha over 2 sd over the square root of n. All right, so when you do this by hand, that's what you're going to have to do. I'll ask for the formula, the substitution, and the result. So the formula is right there on that inferential statistics info sheet. It's d bar plus or minus t alpha over 2 sd over the square root of n. Don't forget that that info sheet is given to you on every exam. You don't really have to memorize that stuff. Okay, so then substitution. Where did I get all this stuff from? Funny you should ask. What I did was I'm going to go to the calculator and I went Stat, Edit. And I have in here an L1 the steel ball and an L2 the diamond. Now let me go back to the problem real quick. It says construct a 95% confidence interval to judge whether the two indentures result in different measurements where the differences are computed. See that as diamond minus steel ball. So they want us to do the diamond one minus the steel ball one. Okay, so what I'm going to do over here, when I go to L3, I'm going to do L2, because that's the diamond column, the second column, minus L1, because that's the steel ball column. So they told me to do that direction, so that's the direction we do. Okay. All right, so there I have my diamond minus my steel ball right there. Beautiful. And then remember, right in the inferential statistics cheat sheet, it says use the t-interval. So I'm going to go to Stat, Tests, t-interval is number 8. So if you either go down with the arrows down to number 8 and press enter, or you just press the number 8 and it will automatically do it. Now we have a column of data, so that's good. It's in L3, that's good. Always leave frequency as 1 for us. And the confidence level is 0.95. Go down to calculate and press enter. And you can see we have all sorts of information. We have the actual answer, lucky for us. And then we also have X bar, which we know is D bar because we told it to do this over differences. Of course, the calculator doesn't know that, but we know that. Oops, hold on, I gotta make that much smaller. There we go. Okay, so the calculator thinks it's X bar, but we know it's D bar. It's 1.44 repeating. And then we know that SD, that's the standard deviation, that's 1.66. And we know the sample size was 9 right there. So we know these two parts and this part from that output. And we also know the result. The result is 0.163 repeating and 2.7256. Okay. Now the only question is, where the heck do you get the 2.306 in there? Because if you're doing this by hand, i.e. on a test, you're going to have to show that. Well, to find out t alpha over 2, you got to remember a couple things. 1, your degrees of freedom is 8, right? It's n minus 1, which is 9 minus 1, which is 8. That's the row on the t-table that you're going to go to. And your alpha was 0.05 because it was a 95% confidence. Let me put that in. So it was a C level was 0.95. So that means your alpha was 0.05, and that means alpha over 2 is 0.05 over 2, which is 0.025. There's the column in your table. So if you grab your table, which of course you'll have given to you on every exam, you can see that this 0.025 column and then row number 8, and there you go, it's 2.306. Now if you have a TI-84, you can actually find it with the calculator. So second distribution, number 4, inverse t, so you pick that one. You say 0.025 because that's your column. Degrees of freedom is 8, and you press enter, and it finds it. Oops, you press enter again, and it finds it for you. Now it's going to give you the negative one, but that's okay. Remember, there's always a left-hand one and a right-hand one. We just want the number. We don't really care about it's negative or positive. So there you go. That's how to find it. So you find it either with the calculator or with the table. Personally, I would use the table because it's faster, but use whatever makes you happy. Okay, so now, hold on one sec. We have our interval, we have every piece of it. Let me just show you real quick with StatCrunch in case that's what you're more comfortable with. So you go to Stat, T-Stats, Paired, column 1. Okay, so sample 1 is diamond because they said they want a diamond in front. So we'll do diamond as sample 1, even though that's actually column 2, right? And we'll do steel ball in sample 2. And then we want the difference, 0.95. And I'll save the differences, why not? So I'll click on that little guy right there and say compute. And there we have it, right? All beautiful. There we are. So you can see them all. Okay, so we have our results right here. And notice how those match up with what we got from the calculator. So if you're doing it for your own homework, you don't really care which way you go as long as you get the right answer. So you could use the calculator or you could use StatCrunch. Either way, you'll get the same answer of 0.1633 right here and 2.726 or so. Now, of course, they might round a bit, so I believe they do when they're doing this problem. So they round, they round D to 1.4, D bar to 1.4, SD to 1.7. See, there's the 2.306 right there. So that when they do it, they've actually rounded the heck out of these things to 0.1 and 2.7. So, that happens. Oops. There we go. So if you want to do that way, then you can do this. You just have to round. So you'd be really careful. You'd say like 1.4 take away 2.306 times 1.7 divided by second square root of 9, enter, right? And they rounded that to 0.1, and then second, enter gets you the last thing you typed in. You go back in here and change the minus sign to a plus sign, plus, enter. And there you go. So 0.1 and 2.7. It's not nearly as accurate as what we came up with the calculator, but there you have it. Okay, so there's that. And then they want to know, what does this mean? Well, remember that in paired tests, let me scroll down to them. Got to get through the chapter 10 stuff. There's chapter 11 starting. Here we go. So paired, right, matched pair is a t-test. Remember that your null and alternative hypotheses are basically these three. And for a confidence interval, it's really this one right here, the two-tailed one, right, that you care about, okay? So if that's the case, if it's a two-tailed thing, the null hypothesis is that there's 0, right, that the difference between diamond and steel ball is 0. And the alternative to that is that it's not equal to 0. So when you look at your confidence interval, you can see 0 is not in there. Both of these numbers are above 0. Since 0 is not contained in that interval, that implies that there is a significant difference between measuring the steel ball and the diamond indenters. I can make a note. So if 0 was in the interval, that would imply that the null hypothesis, which is H is not just mu d is equal to 0, was not rejected / supported. Let's just say supported. Was supported by the data. Right? So since 0 is not contained in our interval, we're basically rejecting, right? Let me put it this way. In other words, not having 0 in the interval means we're rejecting, I can't spell tonight, rejecting the null hypothesis and supporting the alternative hypothesis that, and I'll just copy and paste this. There it is. Hey, come back. There. Okay. All right, I hope that helps. I'll see you back here for more tutorials.